Welcome to PyData Global 2021. I'm happy to have, I'm sorry if I mispronounce your name, Vini Jaiswal with us. And since this is your time, I'll hand it off to you.
Awesome. Thank you. Hello, everyone. Thanks for making time to attend my session today. In this talk, we will learn about how to do data engineering for a successful machine learning project. I have worked with a lot of customers in the digital native unicorn Fortune 500 companies. So whatever I'm going to talk today, it's a combined wealth of knowledge from all those experiences. I am Vini Jaiswal, a developer advocate at Databricks, where I help data practitioners to be successful, building on Databricks and open source technologies, because I highly embrace open source technologies as well as help developers in being a part of the community. So I work on Apache Spark, Delta, MLflow, and other technologies. So let me tell you a little bit about my career journey. So I started off with undergrad in electronics and communication engineering from India. Moreover, I chose this field because I was fascinated by the digital communication between satellites, evolution of smart cellular phones from like heavy electronics to very lighter cell phones, and robotics use cases were evolving and it was becoming more realistic. And then to pursue higher education because I was so fascinated and I loved digital communications. I wanted to pursue my master's from UT Dallas. In telecommunication, but soon after, when I saw the booming age of data, I started my master's in information technology and management from UT Dallas. To further gain industrial experience, I worked at an audit firm as a data engineering intern, and soon after, I did a second internship at Southwest Airlines as a maintenance quality data analyst. Over there, I had fun and fascinating experience because I got to work on the data of maintenance of the flights and providing intelligence around improving the quality of fleets. So that was pretty cool. And then I moved to work for Citi. I had a variety of experiences at Citi, worked there for like over 5 years. And I started working on the infrastructure side when I joined. That's where I was tasked with managing applications which would go on thousands or 400K Citi machines. And then I worked on a project which allowed me to gain experience from moving on-prem to cloud. And that was a huge success. Then I transitioned on to working on data science, and I was instrumental in building data science platform at Citi. Over there, I kind of felt like my experience was getting limited to just the city and banking industry. So I wanted to explore a lot of other use cases and wanted to help out what other AI use cases I can explore. So I started working at Databricks, where I have worked on at least 100 plus data and AI architectures and projects for our customers in the different spaces and different verticals. Now I'm doing developer advocacy for data and AI practitioners globally. That's pretty exciting. You will also find me doing a tech talk or maybe working with developers for Delta Lake OSS. And I'm also co-authoring a book on Delta Lake, the definitive guide. So that was a little bit about me. Now, since we are here and we are going to talk about data science and AI, I want to give you the first sense of why I'm so excited about this and why I think it's a huge opportunity for companies. So as we know, data and AI has massive potential with the growing data in terms of volume, variety, and velocity. Organizations are now combining massive data processing with machine learning and business intelligence capabilities to unlock business value. So let's take a look at how the data landscape is evolving and how the organization are future-proofing the architecture to become completely data-driven and successful with their AI projects. Let's first start with what data teams want. Being in the data space for many years myself, I regularly talk to the subject matter experts in this space. This is what we want. This is what the data teams care about. So before diving into technology, let me give primers on three main asks from data teams. They really want the productivity for their teams, meaning that if they have an AI project, they want to spend as much time on getting the value from the business, generating the business insights, rather than working mainly on the infrastructure side and pulling all the resources into infrastructure side. So they want to accelerate that project, the project work. Second, what are the capabilities that we can drive or we can get to drive new use cases to power our business? That's one of the things they ask for. And then they really want to understand how they can drive efficiencies, because they have amazing talent and they want to make sure that their AI applications are successful and their teams are working efficiently. And some of the themes I'm seeing is around simplicity. Practitioners maybe like, I don't want to focus on things that aren't my core competitive advantage. So those sort of things. So I talked a little bit about how data volumes are growing, and while data is growing rapidly, which can grow up to 177 zettabytes by 2025, which was predicted by Gartner, 80 or 90% of data around the world has still not been learned from. So we are only able to learn maybe around 10 to 20% of the data. So pat yourselves in the back, because here we are, data and AI enthusiasts. We can multiply forces to bring intelligence from this data, and I'm pretty sure we can have successful impact on the AI and machine learning field. So let me walk through some of the important considerations that we can do for machine learning. First is data reliability. I'm pretty sure you must have seen or come across a lot of challenges for your ML projects. This is one of the themes I have seen around data reliability. This often refers to the degree to which you can trust your data. When you train a model on reliable data set, it is more likely to yield useful predictions than a model trained on unreliable data. I'm pretty sure you might have experienced that. For example, if you were writing some data to a database table, but the power went out unexpectedly, right? It's possible that only some of your data would have been saved, while some of it would not. Now your database is in the inconsistent state because your power went out, and now it's like a partial data, and that is very difficult and time-consuming to recover from. This is where having the asset transactionality is actually useful. They ensure that they ensure that you have the highest possible reliable data, and it also ensures integrity, and your data never falls into an inconsistent state because of an operation that could partially complete. Second one is data concurrency. So data concurrency is needed when you have multiple users working on the same data. I'm pretty sure data is like a team sport, and multiple people are trying to be data driven and use your data to make intelligence out of it. So you have to consider those scenarios when you have multiple users working on the same data set. So concurrency becomes very important because for long-running queries on data lakes, for example, where queries and operations may take a long time, this is where having a multi-version concurrency control is important. It ensures that when you have multiple writers who are simultaneously modifying a table, and it ensures that when this scenario happens, they are able to see a consistent snapshot view of the table, and there will be a serial order for these writes. And for the readers, what it means is they can continue to see the consistent snapshot view of the table that the Spark job started with, even when you're modifying the table in real time or during the job. Then data quality. So it happens regularly that data teams are working with a data set and find that variables hold erroneous data. For instance, a timestamp that came from 1485, but you're only expecting a timestamp from maybe like 2001, for example. But 1485, that seems pretty like unexpected data, right? In a similar fashion, we might want to avoid people accidentally adding columns to the data that we're using for modeling, right? This is where having a mechanism to allow you to specify expected data quality and also what should happen to data that does not meet the requirement becomes important. Then comes data lineage. So what if you could see the exact version of the data that you used for machine learning development? And what if you have ability to understand your data dependencies? The ability to track data lineage is hugely beneficial for improving change management and reducing development errors. But most importantly, it provides users the visibility into the sources used for analytics, which allows teams to have increased trust and confidence in the insights derived from that data. You can make much more powerful impact and much more confident decision making if that's available. Then data sharing. So there is a growing demand for ways to share data beyond the walls of the organization with external entities, because I'm pretty sure nowadays you work with a lot of organizations and you want to be able to have a good way to share the data. So what happens is, because you have the constraints from this organization, users are frustrated by these constraints on how they can share their data. Think CSV files or file size limits. And once that data is shared, version control and data freshness are tricky to maintain. Take a group of data scientists, for example, who are collaborating. They are in the flow, they are in the rhythm and on the verge of an insight, but they suddenly realize that they might need another data set to come up with the conclusion. So they submit a ticket to their IT team or data team to access the data, and they wait. In 2 or so weeks that takes them to get access to that data, that time is lost. Conditions change in 2 weeks, and whatever the rhythm they were in, the momentum gets lost. So data sharing shouldn't be a barrier to the innovation. Iteration, right? So one mistake that I see a lot is that when a feature gets into the hands of the customers, they don't think about it as the beginning of the process. They think of it as the end. And I see teams make this mistake all the time, and they build some data-driven feature, they release it, they find the performance to be mediocre, and then they either roll it back or abandon the project, right? And sometimes these organizations even come away with the mistaken impression that ML is therefore not actually very effective for the problem on the hand or on their data, when in fact they kind of quit at the beginning, right? So start small and try to iterate over rather than waiting for perfection, but do consider it as like a starting job or iterative process. This is the right way to build, is to build and plan for iteration. You should assume that you are going to start out with something that works okay, and you will need to measure performance, collect more data, and iterate till it's good enough, right? And that's partly organizational, like having to invest time and iteration, but it's also how you go about developing those models. You need to put in place any of the instrumentation that will inform the iteration process. And you also need to think about the infrastructure that will support the rapid experimentation, because when you try to iterate, think of it as like, failing fast and then just picking back up and moving on with another experimentation. So that infrastructure becomes also a critical component. And then cost efficiency. With the growing data, now you have to think about the storage, you have to think about the compute, and then maybe you have like a lot of infrastructure problem, or maybe, so many tools that it's hard to manage. Also, back in my Citibank days, we would do capacity planning 2 years in advance, 1 year in advance. And then, sometimes what happens is whatever problems you have at hand right now, or whatever decisions you are making right now, is based on like some assumptions and maybe the trends you are seeing in this, in this current time. But what happens in 2 years, we don't know. So, that's one of the problems. So what is happening is the adoption of cloud has been like increasing, and organizations are embracing the cloud culture. And this robust services that are made available by our cloud providers like Amazon, Azure, Google Cloud Services has made it easy and cost effective for organizations to quickly get started, and they don't have to like have a heavy investment right at the get-go. They can pay as they go and what they consume. So they don't have to think about necessary debts in the future. Moreover, the tools like Delta Engine, Apache Spark, we are here at NumFocus. All of these tools are there to help developers and ML experts to leverage the best practices, as well as how they can perform the queries efficiently. So Delta Engine and Apache Spark enables you to have high performing queries. And then to make machine learning projects more productive, the machine learning platform needs to foster collaboration. We all agree that it's a team sport. So it should allow participants to use the tools, languages, and infrastructure of their choice. So it should, it should provide a platform to bring together all the teams, data engineers, data scientists, DevOps in one place to share, learn, and collaborate. Data engineering and data science is kind of a little bit different from software engineering space in that regards, because when you are building a software, it's all the software engineers who are working towards it, right? But when you are building an AI application, you need to think about data engineering. You need to think about how you're going to host that data, how you're going to process that data. You need IT infrastructure, you need data scientists. So all of these people are there as your task force to make AI applications really successful. So basically, you need to have a secure and collaborative environment to foster that successful machine learning project. All right. So maybe I'm overloading with too much information. Please do ping your questions in the chat, which we will take at the end of this talk. So if you look at just the data platform, what it is, and let's break it down into 3 components. First is there is data storage. The raw data that goes in there, think about it as raw ingredients. Then data management and governance is how you organize all of the raw data. So think about how do you structure, how do you put security around it, how do you clean it up, and how do you make it discoverable. Think about this as an organized pantry that has quality control, it has labels, and basically doesn't allow kids to go in there and just grab whatever they want. And finally, it's data workload. So how do you take all these raw ingredients and turn it into something meaningful? It's the engine that converts data into insight. So let's put actual technologies into this context. I'm a big fan of analogy, and that's why I'm taking this food pantry as an example. So let's put actual technologies into this context, and you will understand why data management is so critical. So let's start with a data warehouse. Back in 90s, data warehousing was one of the very key critical components. And, back then, people were thinking about how they can manage the data with the growing need of growing evolution of software. People were just thinking how they can make some intelligent decisions. So that's where the data warehousing got started. Over the period of time, this is where data analysts and business users get insight from structured data. From the storage perspective, it is the proprietary storage for structured data only. So think about this like I can take only the fruit, that's it. I can hand a fruit and it puts it behind some hidden drawer and I will never have direct access to it. So that's one thing. After that, it really has good data management capability, right? Because as I said, whenever that they did ETL processing back then, all of the missing data as well as any corrupt data would get eliminated during the ETL process, and only the good data gets through the pipeline. So some of it, duplicate data or noisy data gets removed, but we will see how important it is and how it evolved. But anyway, for ETL processing during warehousing times, they had very good data management capability just for those reasons, because they could manage good data, right? It spends a ton of time making sure that only the good fruit get in there. It's basically laid out. You can find exactly what you need with labels, expiration dates, and only the ones you can access. This is where data warehouses spent a lot of time and they nailed this capability, right? And then it's only for SQL and BI workloads, right? For data warehousing, it only supports, a structured and semi-structured data, for example. And sometimes it only has SQL interface. That's about it. So think of it like in a kitchen, they gave you an oven and you can only make fruit pies. You can make the most fantastic fruit pies in the world, but if you want to make a pizza, you want to make a steak, that is off limits. So that's how I like to think about it. From data standpoint, ML is out of picture in data warehouses. So the best example I can think of is this is what it looks like. And this is like a warehouse where have this well-organized world where all the fruit is perfectly cut up for you. It is available, but that's it. That's all you're gonna have available. If you want to put something else, you really can't, because it's really inaccessible. From a data lake standpoint, this is where data scientists can explore data and build models from any data. But what data teams want is they need both BI and ML, right? And this is hard in the old paradigm. But now if you go to data lake, it said that I don't just want the fruit, I want an entire grocery store. It's a storage for all your data. Anything that comes, I want to be able to pull it for you. And it gets organizations excited because you have tons of data that needs to be added value to. So you just don't want a portion of it, but you want all of your data to be hosted. Now, some of them are great, but what happens is it has open storage for data, which is awesome. And then it lacks data management and governance, because you must have heard data swamps, right? Because it's literally garbage in and garbage out. There is no control around it. And then workload, it does support ML and BI, but as I mentioned earlier, successful components of ML, it lacks some of the reliability, quality, lineage aspects. So those are some of the challenges with data lake. And this is what you are trying to get value out of. Literally, like, if you're curious, this is a picture of grocery store after an earthquake. Everything is on the ground, half of it is broken. You don't know what is good quality or anything of that sort. So this led people thinking that this would never work. So now the key question is, what if there is a Goldilocks way in the middle of data lake and warehouses? What if I could borrow that is a data management capability, for example, reliability, integrity, security, quality from data warehouse, you can go get it, but you should still support all of the workloads, right? Because data warehouses just support BI use cases, but my use cases are not just limited to BI. Now I want to do AI and machine learning. What if I don't want to be locked in proprietary store? I want to own my own data. It needs to be in a format and have the flexibility for the long term. People are thinking of things in a more future oriented, multiple year down the road mindset, right? So there's so many urgencies in the enterprise that it's hard for people to take a step back and say, well, 3 years from now, what will I have wished I did? So keeping all that in mind, you need to also have easy integrations with other tools, because you will have different skill sets in your team. So you want to be able to integrate with your entire ecosystem. So what if there is a way to bring best of both worlds, from data warehouse and data lakes? This is not a dream anymore. We have lakehouse now. So this is what lakehouse is. The lakehouse is effectively saying that I can bring all of the data that and have the core data management capability, a foundational compute service to support all the primary use cases. And you can have metadata caching layer. There is on top of data lake, and it can support business intelligence and AI applications. So when you hear us talk about Delta and how critical Delta is, this is where Delta adds transactionality layer, and I will talk in a little bit. But all the practitioners that I talk to, they are thinking about this lakehouse paradigm. So with a lakehouse, much more of your data can remain in your data lake rather than having to be copied into multiple systems, which can be costly, as well as you need to think about governance. You no longer need to separate data architectures to support your workloads across analytics, data engineering, streaming, and data science. Instead, you are able to achieve one common data foundation for all your workloads. So this is what Lakehouse is. So with Lakehouse, all the data teams are happy. They can unlock bazillion use cases from the data that they generate. And, it keeps all the data teams happy. So remember the slides from earlier, all of these were the considerations. Now, this is what I have seen Lakehouse architecture at Databricks, where, it has like a full Databricks machine learning platform, which is a data native solution built on Lakehouse. And one of the key critical enable for this Lakehouse innovation is Delta Lake. Delta Lake provides reliability through asset transactions because it has a transaction layer. You can be sure that all operations in the data lake are either fully succeed or fail, with the ability to easily time travel backward, have the lineage for your governance. And Delta Lake is underpinned by Apache Spark and utilizes advanced caching and indexing methods. So you remember when I talk about query performance, this is where it comes into the picture. And finally, Delta Lake also provides fine-grained access controls, which gives you much more control who can access and what data in your data lake can be accessed. One more thing I mentioned about was data sharing. So now we have Delta sharing as well, which enables organizations to, just break the ceiling and share their data with external teams in a much more reliable as well as efficient fashion. So would you rather live here or here? So Lakehouse is a mindset, and we have to welcome it in our hearts. At Databricks, we define the Lakehouse, we take it religiously, and even have the music for it, which was repurposed. So that's about my talk. And I'm also co-authoring this book. If you are interested to learn how you can leverage Delta Lake to bring reliability and build efficient ML pipelines, please check it out. Also, you will find me somewhere talking about Databricks or Delta Lake, and I always give tech talks to the community because I'm a huge champion and advocate for community. Please reach out in case if you have fascinating projects that you want to collaborate on or just learn anything, educational content. We are here to support that. And these are my links to on the social media. Please check them out. If you want to connect, I'll be happy to connect with you to answer any questions as well as like do any kind of collaboration. With that, we will take questions. But thank you for being here and listening to my talk.
Thank you for being a speaker this year. Let's see, and we're about to. And I invite anyone else who wants to continue the conversation to our, oh, we got one quick one. What is your opinion on Iceberg? When can using data lake be a poor choice in enterprises?
Yeah, good question. So Iceberg, similar to Data Lake, there are some some here and there, plus minuses for Delta Lake versus Iceberg. We are working on, some comparisons around it, but basically companies are, embracing all these technologies, the tools of their choice. So I would say Iceberg is in the similar realm as Delta Lake. So I think companies are kind of combining it with other technologies to use it. I haven't used it personally, but so that's my comment around that. And your question is, when can using Delta Lake be a poor choice in enterprises? So sometimes if you have like a smaller data set, for example, and if you don't have a huge workload, you can maybe get away with working on the edge.
All right. Triple thank you to everyone who came out. You have a wonderful day.
Awesome. Thank you all for joining, and thanks to our amazing moderators. Appreciate it.